The most important legacy is if one law enforcement officer or one civilian in the line of fire goes home to his or her family that night because our plate did its job when it was called to do its job, that one person going home to their family is worth all the blood, sweat, and tears that have gone into building this company.
Over the last decade, personal body armor is something that has become much more culturally acceptable. Whether it's shown in popular video games where you can add armor plates to your character to stop incoming fire, or whether it's CrossFit athletes and other people in fitness sports who are wearing a plate carrier and some form of training plate inside. Now, at the same time as body armor being much more culturally accepted, it has also been a very controversial subject and a very controversial type of product because it is now much more widely available to consumers. And there are new companies popping up around the market that want to sell to the consumer market of civilians, possibly not to military law enforcement organizations because of the regulations and the requirements. And there's a lot of snake oil that exists within this industry for this product type. But with all of this said, what does it take for a body armor plate such as this one to actually reliably and consistently defeat a rifle round such as this one? Let's go find out. Not sponsored.
Not sponsored by Planters.
I'm here in Aberdeen, Washington, which is the home of Hesco Manufacturing. In this building behind me is where they manufacture tens of thousands, if not hundreds of thousands of rifle plates. And I'm looking forward to seeing just how those are manufactured. So the first person we're going to be talking to is Micah Carey, the president of Hesco. Over the years, I've had the opportunity to tour a number of manufacturing companies in the firearms industry. And one of the things that I look for right off the bat is how many steps it takes for them to complete a single product from their main lineup. At Hesco, it's around 8 processes, 8 steps to complete a single composite plate. And it all starts in receiving.
From ceramic to rolled goods to foams of sheet, this is where it comes through. After the material comes in, the first work cell it's going to stop at is the Gerber, and the Gerber is right here behind you. So here we have the Gerber machine. We have this roll cart that's full of rolls of polyethylene already. Polyethylene is a shield material made out of what people would commonly know as dental floss. So it's a bunch of fibers, and there's 4 different layers in it, but you can kind of see the fibers up there. All composite armor is made with some type of backer material. It can be an aramid, it can be a polyethylene, it can be an e-glass.
Right.
And then depending on the threat, it also has a ceramic. So once we get it out of the box and on the roll cart, we'll bring it over here to the ply cut table, which will pull it out at a set length. But one of the things the ply cut table lets us do is it lets us visually inspect it. Each of the suppliers give us an inspection report of what they saw, and we're able to check that as we go through each of the roll and make sure we see the same thing they do. Once it all is rolled out, a number of sheets counted by the Gerber operator, that is then taken up to the Gerber machine. So we load in the right file that says the size. We're cutting this to Sappy medium right now to make these plates, and Steve is going to have the machine run and cut through all of it. Once he cuts through all of it, he'll use that scale to check on the aerial density to make sure there's enough fiber in the material as well as enough glue before we go on to the press. So Lucas, back here at the press, we have the material that comes back on the carts, but we have to make sure we get the right amount of material for each plate. So this is the area we call layup, and we're going to use weight and ply count to figure out how many plies we need in that backer. So we're going to take the plies of that shield material and lay it all up and give it a weight, and then we're going to mark it. We're going to mark it with a work order number, plate number, model, and size. and all that information of the lot and the weight and the material that was used in this plate will be put in the computer so we can keep track of it. This is what we call a layup. It's a set amount of plies, and we'll take this layup and put it in the aluminum tools. There are several aluminum tools over here. The aluminum tools are then put into one of our two presses, either the 800-ton press, as you can see we have an operator right there working on it right now, or the 920-ton press. So that is where it is unconsolidated. And then this is the plate, how it's going to look consolidated. So you can see it definitely got a lot of thinner. It went on a good diet. You know, it goes from a flat layup to a multi-curve plate. And so from here, the plates will go two different ways. If it's just a backer,
Right.
then that means it needs a ceramic and it'll go over to the oven. But if it is like this one, this is just a pure PE plate is what we call it. This will just go to the water jet and then it will go on to wrap. So here at the oven table, the oven assembly table, we take ceramic, we put it through the process with a backer, then that will go through another oven cycle. It will then become a bonded plate through the oven. And so you'll have a ceramic front and a backer, polyethylene backer on the back. Okay. Once we have this ballistic core, whether it comes from oven with a ceramic or it came straight from the press through the water jet to get trimmed down, we go over to wrap. But let's stop by the water jet and see if we can see a plate getting cut there.
Nice.
This is a backer that was consolidated in the press.
Yep.
It is a little bit oversized, which allows us to go in the water jet and trim it down to the exact size we need. Okay, so after the water jet is done, the plate will come here to wrap. So we've seen the composite armor with the ceramic finish up over at the oven. We've seen this one consolidated at the press, move to the water jet and get trimmed down. And then it comes here to wrap so that we can finish the plate and get it to what everybody is used to looking like. We have a bunch of plates that are wrapped over here. We're doing some side plates right now. And on this side plate, we're going to put some back foam, edge nylon, and all that will go on this plate and be wrapped up. All of that is put down into the computer to keep up traceability. Once it's wrapped and it's all done, we mark it and we come over here and we'll take it from this wrapped nylon and we'll start putting on the labels. And so you can see that the label, this number here, the B25, ties to our work order number, which then also has a serial list. So now if anybody gives a serial number list, we can go all the way back to the work order and all the material that was on it. Once the label is on it, we'll put it through our PSA oven. But every work cell has what I call a critical to quality, and they have parameters that before their product can move on, they have to measure them, record them, and enter it into a computer which checks into a database to make sure the plate is being built right. Once plates are done, they come over here for packaging. The first thing is somebody's going to take this order fulfillment paper and they're going to make sure that everything the person ordered is over here to get packed up. Each box is then marked and weighed, and then that information is marked down on here and on a pallet order, so we know what serial numbers are in each box. And then we'll ship that to the end user. But the real bit that helps is if the shipment's ever lost or someone decides to take and steal a box off, we know exactly which ones it was.
After the tour, Micah talked to us about the NIJ certification process. He then showed us the teardown lab. This is where they take plates from the various test labs who shoot their plates, and they further inspect them. They rip them apart, and they see what needs to be changed to improve the product.
Here at Hesco's ballistic deconstruction lab, we don't have any bullets that we fire in here. All the bullets here are in nice little baggies or in plates. But you can see that we do a lot of testing. There's a bunch of plates as you come in the door. Every counter surface is covered with plates. So here we have two example plates for NIJ 010106. We have this one here, which is basically a level 3. So this was tested with the M80. And you can see that this plate is shot 6 times. So the first 2 shots, this one up here, and that's a 2. These ones are measured for back face deformation, BFD. You can't get larger than 44 millimeters on any of the first 2 shots on any of the plates. However, the rest of these, the 3, the 4, the 5, and the 6, as you can see, the plate definitely degrades. And here on the 6 shot, you have a large deformation. And that still passes NIJ because they read the first 2 shots. Once you're certified and you pass that test, you will get a certification letter. You'll be listed on the NIJ CPL, and you will now, they will now put you in the rotation to do what it's called a fit test. It's similar, except a lot more plates for the level 4. So the threat for level 4 of NIJ 106 is M2AP. Thankfully, it's not 6 shots because your back face deformation would be insane.
Yeah, it would be. Yeah.
On the 6th shot, but on the first shot, it's not bad at all. That has to be under 44 millimeters. Much like this one, the shot has to be further than 2 inches from the edge to be a fair shot. Because there's only 1 shot on this one, where this one, it's, you know, they have to be 2.5 inches away from each other. If they're closer than that, it's not technically a fair shot. You asked about the shot pattern. So typically everybody puts these the furthest away like this. And that is one of the ways you're only going to pass the 44 millimeters. If you put those right together, the second shot, because you've pulled those fibers already, won't perform. They won't do that.
Because every shot, you have all the fibers that are, you know, each direction, you know, like this.
Yep.
Is going to just sink it all in, and then
Right.
a shot next to it's going to pull all of it together. And
Yeah. That's part of the reason how it absorbs the energy across the
Right,
whole
yeah.
plate. Is that fiber initially, the first fibers break because the bullet's going too fast.
Right.
But they slow it down just enough that the bullet begins to slow and get caught by those fibers.
Yep.
And all those fibers pull a little, and then they break, and
Yep.
then they pull a little bit more, and in some cases, like the 6th shot, they pull a lot. So then a little bit of, what is different between 06 and 07. 06 has 2 threats, right? They have the M80 and the M2AP. Whether those are actually live threats, again, it is a standard that they were testing to, something that they can feel like they have consistent ammo
Right.
for, because we don't want to add that variable to. But as everybody knows, the big threat for everybody lies in the middle of these with the M855 green tip, right? Or even the MSC, but probably more importantly, the M85 green tip. And the industry kind of said, okay, so you gave us 06, but this is the threat people are getting shot with. So the industry created what they call the 3+, or some people call that a 3++.
Right.
At Hesco, we call it a 3+, because our polyethylene backers or our polyethylene plates are already pressed at high tonnage, so we can pick up the MSC with these plates. No issues asked. It's when you go here and you need that ceramic to start breaking
Right.
up the penetrator for your 3+, your green tip type plate. So which would be like a 3810. But in NIJ 10107, they created the RF2, which is for that. So RF1 is NIJ 10106-3. RF2 is NIJ 10106 3+, technically, the green tip, right? Didn't exist before.
Right.
And then RF3 is still your M2AP.
Gotcha. So it's bringing the NIJ certification standards more into the modern era. Is
Agreed.
That...
And addressing the threats we have, right? Because
Yeah.
M855 is definitely a threat that we have out there.
Yeah.
For it. The other bit of 07, they changed the shot pattern. So 07 is designed initially for a 3-shot. You can choose to go 6, but it is designed for a 3-shot. And what they do is they divide the plate in half. They put I think it is like a 1-inch band that's centered on 2.5 inches around the plate. And then they say you must shoot it once below the center line and once above, and then a shot between the two.
All right, so to wrap this all up, the NIJ test, because obviously we have this plate that looks very nasty back here, but none of the bullets came through, is my understanding with this plate. Is the NIJ test set up to be realistic, or is it just a scientific, consistent test?
So, yes, in real life, if someone tied you to a pole and then shot you in this pattern, that is not the NIJ's intention. That's not what they're testing for, which is what would have to do to get this done, right?
Right.
Right. But that's not what they're testing for. They want to make sure that on a one-shot M80, or maybe even a two-shot M80, where you're then
good to go.
on the ground,
Yep.
that back face did not do any permanent damage. They then say, we want a safety margin in that plate to make sure you don't get any penetrations.
Yeah, we started in this building a card table and 2 Cabela camp chairs. Literally what we started with. And so you've toured the facility, you've been downstairs. There was one electrical outlet in the entire building downstairs.
wow.
And so everything you see, all that overhead piping for cooling and vacuum and all those other resources that it takes to run a factory, the water jets, the presses, you know, we physically brought all that in and geared up this facility. We spent some time flying under the radar. We didn't want our we have some very worthy competitors in this industry. We didn't want to tip off our competitors to what we were doing and how we were doing it and why we were doing it. So we spent a year in outfitting this facility and in product development and testing before we even released our first product. And I'm proud to say our first customer was our local SWAT team. We, as an indicia of the character of who our company is, what our values are, what we stand for, we thought the very first thing we'd do with our very first plates is support our local community. So we donated plates to our at the time, very under-equipped SWAT team alliance that consisted of 3 communities in the area. And we had a grand opening ceremony here and presented plates to our community. And that was the start of our business. And we took it from there.
How did competitors react to you guys showing up on the scene and not knowing what to think? Or
They were, I think, startled. How does anybody start a body armor company and come out with a great product and win a U.S. Coast Guard contract in their first year of existence without them knowing about it? How did, and like I say, we have very worthy competitors. Some of them are household names in this industry, and there's a lot of them called and said, "Who are you guys? What are you doing? Where'd you come from?"
That's awesome. And what was the initial draw to your product, or what was the technology that you had that the armor companies saw or that clients saw, like the Coast Guard, and went, "Hey, this is cool. We want to get in on this"?
So body armor is interesting in that if you meet the spec, you meet the spec, right? If it's a level 3 plate, it's 6 rounds of M80 ball. If it's a 3+ plate, you're picking up some special rifle threats. That's up to the manufacturer. So a lot of companies can meet the spec, but can you deliver the rest of that equation? Can you provide the customer service? Can you provide the expertise, the know-how, and actually take the time to understand your customers' needs?
Yeah.
I mean, we were the subcontractor on Armor Express's CBP program. We produced 100% of those plates, $20 million IDIQ. And the reason we won that is we just spent a lot of time understanding what CBP's needs were, what they were looking for in a plate, and we call it listening to the voice of the customer. And that's one of the founding principles when I started the company. We will listen to the voice of the customer. We're not going to be know-it-alls. And we're going to build a product that meets their needs.
What is the legacy that you are hoping to leave behind with this company that you started that is producing this awesome product that people are using? Is there something specific that you are hoping will be there, which is also maybe why you started the company in the first place?
Yeah. I have a multifaceted answer, but I just have an enormous amount of personal pride in job creation. I just love the notion in our country, creating jobs is so important. It gives you your place in the world, your place in society. It helps you care for your family. It helps you care for your community. It helps you make the next generation better than yours. So, job creation, we've created a lot of jobs here at Hesco Armor at the time, depending on the size of our contracts at the time. Sometimes we've exceeded the 100 individuals in this building. And that's a fantastic legacy in my mind, to creating jobs for a lot of people. And then the most important legacy is if one law enforcement officer or one civilian in the line of fire goes home to his or her family that night because our plate did its job when it was called to do its job, that one person going home to their family is worth all the blood, sweat, and tears that have gone into building this company. We get reports of saves from all over the world, Ukraine, the Middle East, domestically here in the United States. We get images of people, pictures of them that our armor has saved their lives. And that feels incredibly gratifying and feels like your time is well spent.
Has there been something specific over the last number of years that you've been here that was particularly impactful for you in running this business and being involved in this business that has really stuck out to you being involved here?
So much has been impactful. But I'd say on the personal, my personal journey with this company has been watching it evolve. We were a startup, as I said, with two Cabela camp chairs and a card table when Ryan and I started this company. And we've now have what I'd consider one of the world-class ballistic engineers, Nick Bell, who's, in my opinion, second to none in the industry. We couldn't hardly have imagined that 13 years ago, that we'd have that kind of talent in this building and that kind of process, that kind of testing, that kind of data gathering. So that's been quite a journey just for me to watch how the company's evolved. And I feel with the talent we have in the building, I can ride off in the sunset here one of these days in a year or two and feel really good about who's here, what we're doing, and the culture that we'll have in this building. I've had a very varied career. Once I found armor, I've stayed with armor because I love it so passionately, and nothing's ever been more satisfying to me. But I've been everything from a wildlife biologist to a commercial fisherman to a big game guide in Alaska to a woodworker, a gazillion different things. And each one of those experiences in life was just do it. Have a can-do attitude, and you'll be amazed at what you can accomplish.
That's really good. Now, as far as being in the armor sector, because you have a wide experience in a lot of different areas, what are some of the unique challenges that are posed by being in this space with the competition that you have? And what were some of the solutions, sort of the ways you got around those challenges when you ran into them?
So one of the things I've learned, and sometimes painfully over the years, but I have an adage that is not my original saying. One of my mentors a long time ago said this to me, and it was, Joe, he who shoots the most knows the most. Period. End of discussion. And when you're a startup and budget's constrained, you feel like you've got, say, a dozen successful tests, and you feel like you've got a great plate design. And what I've learned and observed, because I'm not an engineer, is you don't know a ballistic plate until you shot it 100 times. Because bullets are funny, and they do funny things and weird things and very unpredictable things. The very nature of a spun projectile, it's quite unpredictable.
Yeah. Is there a misconception about body armor that if there was one misconception and you could write it right now, what would it be?
It would be body armor is not bulletproof. Nobody's body armor is. Body armor is bullet resistant. So what we try to do is we set a standard internally, how we're shooting things, what our shot patterns are, and we design to that standard. We don't vary, and the results are favorable that way.
What do you think the future of armor is going to be?
I don't, I like to, I'm not an engineer, but I like to fantasize that there'll be significant improvements both in the polyethylene backers that we use, the catcher's mitt part of the plate, and also on level 3+ and level 4 plates, which have a ceramic strike face. I like to think there'll be innovations in ceramic chemistry and other types of innovations where we can reduce the thickness of the plate, reduce the overall weight of that whole composite system, and improve it for the same performance or better performance. And ideally, for folks like you at T.REX, improving the cost basis. I mean, that's another whole area of innovation. There's a saying, like, at what point is the juice worth the squeeze? How much lighter does it have to be if you're only shaving off 0.2 of a pound, but you've doubled the cost of the plate? That doesn't make sense for an individual citizen nor for a law enforcement agency. One of the things I'm proud of, I'm proud of so many things here in what we've accomplished. One of the things I'm proud of, this is a tech sheet for our, and I can give you this. This is a tech sheet for our level 4 plate. And, you know, a level 4 plate has to stop 1 round of APM2. So a lot of our worthy competitors will put out, this is a level 4 plate, stops 1 round of the APM2 round. We take a look at all the other threats we test this plate to. That's, not everybody does that, I can assure you, because every one of those is a lot of dollars to do that testing, and I'm talking many, many shots, not just a couple. And then we say how many rounds it stops, and most people publish that information for a 10 by 12 plate, a standard shooter large or a sappy medium type plate. We hold ourselves to an entirely different standard. The industry secret is what a 10 by 12 plate will stop. You can't even fit the shot pattern on a smaller plate like an 8 by 10 in some cases. So we publish our threat profile based on part size and dimensions.
Yes.
And yes, it does go down. Some threats at a 10 by 12, you can stop 6, where we're comfortable claiming 3 on an 8 by 10 plate. I don't know of anybody else that bifurcates their threat matrix by part size.
Right.
But when I started doing that and came up with this matrix, which is now a lot of people use in the industry, something similar, I felt like we had to be transparent with our end users. What we do, and just as importantly, what we don't do. Don't create a false sense of security or make a claim that you're inferring you do something when you really can't back that up with data. And if we put 3 shots on there, it probably does 4 or 5. But it's where we're comfortable publishing the data, what we can stand behind. And I think that's a really important thing for people to know what a plate does and doesn't do. And they also need to understand that we shoot to a standard. So they're welcome to go shoot our plates in the backyard tied to a tree stump, but that's not the NIJ testing protocol, so the results may be different. Doesn't mean the plate's better or worse. It just means it's not tested to the same standard that we designed it to. As we've evolved as a company in the armor industry, and every company has had some hard lessons, we're no exception. Our solution to having fewer hard lessons in the future is to test, and then test again and again. And then I'll give you an example. We have some new plates that recently were certified under the 06 standard, and that last wave of certifications of CPL listings that were granted by NIJ. We will actually do 3 mock NIJ certifications, everything, whether it be wear and tear or heat and cold or the ballistics. But we'll do 3 full mock certifications to make sure we're 100% confident in that plate before we send off for our real NIJ certification with the samples. We learn a lot in that process. And we also learn about what to do the next time with the next generation of plates, you know, where we might improve in the future. So it's a lot of money is spent in testing, and it's money extremely well spent, in my opinion.
So in the process of creating this highly specialized product with the intent to preserve life, and with the regulatory institutions that are managing the testing and the parameters, I'm assuming at some point there's going to be some failures within the testing or as you're submitting plates. Has your company encountered some of that, and how did you go about resolving it?
We have, and with NIJ, and it's a relatively new surveillance program that they instituted. If you're an ISO certified company like us, it's every 2 years on a plate. If you're not ISO certified, it's once a year. And if there's an issue with a fit, NIJ at their option based on the nature of the problem can issue either a safety notice or just an advisory notice. You had asked at one point when we were talking, what are some of the things you're most proud of at the company as one of the co-founders? I'd say one of those experiences comes to mind. We had a model called the 3610, which is a very, very robust, well-proven 3+ plate, performed very, very well, been shot hundreds of tests and had never had an issue, and then suddenly there's an issue. And we analyzed what the root cause analysis was, and no matter what we do or what we say, there will always be a perception issue. Our brand, our name, our credibility, our integrity is worth much more than that. So we sought and received the funding to do what we called a warranty corrective action. We didn't have to. There's no such thing as a recall under NIJ. It's purely voluntary on industry's part. But at some considerable expense, I don't even like to think about the number, but it was a lot of money. We took plates back in from far and wide. Life is too precious to leave anybody unprotected. That was relying on your plates. And that was a tough thing to swallow financially, but it reaped huge rewards for us. Our credibility in the industry with some of our competitors, I got calls from our competitors going like, holy crap, no armor company does what you guys do. And but that's who we are, and that's what we're going to continue to be.
That's really respectable. So now that we've seen how body armor is created, specifically composite body armor, the next part of the process to go and learn about is testing. Obviously, there's a lot of rigorous testing parameters that they are subjecting the body armor to, different standards. Now there's 2 NIJ standards in particular, 06 and 07, that they're having to work around. So we're traveling now to Phoenix, Arizona, where we are going to visit Energetic Test Labs, who does a lot of the testing for Hesco prior to them sending plates to actually be tested for the NIJ certs and also for the fit tests. So we're going to fly out there, check that place out, and then go home, and I'm looking forward to seeing how they do stuff. So this morning we're here at Energetic Test Labs here in Phoenix, Arizona. This is one of the 5 or 6 NIJ credited test labs who conducts testing of various plates and armor for the different NIJ levels, but they also provide R&D testing to companies. Companies can submit their plates and send them in for testing prior to submitting for certification, or companies who are just testing plates during the development process. So we're going to get an inside look at how they're conducting this testing, and they're going to educate us on what that looks like. So let's check it out.
We have our shipping and receiving area over here, storage of any armors, helmets, anything that's been shot that we might need to get back out the door. This is our submersion tank here. So just a large tub of water with controlled temperature and pH. We have a RO system that we designed and built for controlling the pH and temperature of that water. The RO system here also feeds into the conditioning chamber that I will show you in a minute. But essentially it's just a big chamber of water controlled to a certain temperature. With hard armor and soft armor, you would take that piece of armor and you would submerge it in the water at a prescribed depth below the surface, and you allow that to sit for 30 minutes, pull it out, let it dry for 10 minutes, and then shoot it ballistically. This is our thermotron. This is the conditioning chamber. So you'll see here, capable of extreme temperature lows and highs, as well as humidity that can be induced in this chamber. RO system obviously helps with the humidity. You'll see in there right now is one of our soft armor tumblers. It's essentially just a drying machine with some fins in it.
How do you mount hard armor in here when you're conditioning it?
So this tumbler actually comes out, so you'll see that's our second one right here. So when we're doing hard armor, we pull this tumbler out, and then we have wire racking that runs north and south. The plates are to be stood up when we run those. So for hard armor plates, they're stood up and they're run at temperature and humidity. The difference between hard and soft armor in the thermotron conditioning chamber is that after the 10-day cycle of constant temperature and humidity, hard armor goes through a 24-hour temperature cycle, which is up and down of temperature extremes, low and high, and varying humidity to make sure that there's no temperature shock or extremes that could invalidate the results or compromise the ballistic performance of the plate. Okay, so this is our hardness tester. So this is the piece of equipment that is used to test the factory 31 mild steel core rounds. Essentially what's gonna happen in the 07 standard for validating the factory 31 mild steel core projectiles, we have to take a bullet, a full bullet, and we have to extract the core. So that means that we need to take a tabletop lathe or something to be able to cut the jacket off of that core without damaging the core itself. So we perform that with a tabletop lathe. We take this core and that's what's placed on the table here. And then that is what is tested for its hardness. And we have a procedure obviously for calibrating this machine. We have tolerancing plus or minus on where this core needs to be in accordance with the NIJ standard.
Wow. How many other labs are doing this or can do this?
We are currently the only laboratory that's certified to perform hardness testing to NIJ 0123, Appendix A, I believe it is, which is the hardness testing of mild steel core projectiles. So any of the projectiles that are used for certification testing, any of the Factory 31 projectiles, will come with an ETL test report that validates the hardness for that lot that's being used for testing.
How much variance as you're testing these do you run into, or is there not a whole lot?
There is not a whole lot from our experience, which is a good thing. And that was, I think, to some degree the reason that the NIJ chose to pursue the Factory 31. There are some other mild steel core projectiles, namely something like a Chinese manufactured round, maybe a M1943 PS ball or a Type 56, where you would see a larger variance in both core hardness that could then translate into grainage differences of the bullets. And so in order to subvert that, the NIJ specified that the mild steel core projectile to be used in 07 certification testing is the Factory 31. And we have seen that that Factory 31, the few limited lots that we have tested have fallen easily within the tolerance as required by the NIJ on hardness testing. That's the hardness tester. What we've got here is our label durability tester. And this is a new addition to the NIJ 010107 standard as well. Previously, when you were testing NIJ labels for ink durability, you would have a manual, a tester, take a piece of cotton, soak it in a couple different fluids, and then rub that label for a prescribed amount of time. What we're doing now is to eliminate the human variability, is we have a machine with prescribed weight and articulation of the machine that will labels placed here, and then the machine articulates back and forth with various substrates, including isopropyl alcohol, denatured water, all these kinds of things that we're using, soap and mineral oil, different challenge fluids as they're called in the standard. And those are soaked, these pieces of nylon are soaked as the abradant in that challenge fluid. This is then placed on the block here, labels placed underneath it, and it's rubbed in accordance to a prescribed number of cycles. Essentially what we're looking for is to make sure that the ink is still readable after all of those.
So they can see the warranty information, where it came from.
Correct. NIJ seal, model information, warranty information, all of that is important to maintain on the label. What is also crucial here is if your label fails ink durability, you do not necessarily fail your certification. We as the test lab would reach out to the armor manufacturer and say, hey, your label has failed, please resubmit a new label. If you change construction, include that in your documentation so that we know what you're using, and resubmit. So whereas if you had a ballistic failure, or if you had a conditioning failure, or some other portion of failure in construction, layup, anything, that would fail your model. A failure of the label during durability does not constitute a failure of your certification.
If for the most part, are people's labels pretty good to go, and really
that's a good question. This is I would say, if you ask my opinion, this is going to be a sneaky portion of the standard that not a lot of people will accommodate for. Essentially what you're doing is 2,000 back and forth cycles per challenge fluid on a label.
And how many challenge fluids are there?
3. And so you're rubbing it dry, and then you're rubbing it with the alcohol, and then you're rubbing it with a mixture of water, soap, and mineral oil. So I guess 2 if you really consider.
Is there one that simulates salt water?
The mineral oil I think is meant to simulate both the cleaning instructions, because generally they tell you with a nylon covered plate you're supposed to use dish soap. So I think it's meant to simulate that, and I think the mineral oil to some degree is meant to simulate a little bit of that. And so it's a lot of cycles. It's a lot of cycles that the label's going through, and you'll feel the heft on this block. It's not light.
Oh, no.
And so if you've seen any thermal transfer labels or any of the typical labels that go on armor, if you're using kind of a lower end thermal transfer label that doesn't have a lot of sticking power to, let's say, a polyester face stock, you could run into serious trouble with the label durability test. And so this is one that we've been advising people to pursue and look at least just validate it. Send us your 06 label, take a look at it, we'll check it. If something needs to change, we'll let you know. This is kind of our clay preparation area. So when we were talking about repeatability of tests and understanding what the backing material behind your armor is, this is where clay comes into play. So you'll see we have 3-4 ovens here that are currently operational. All of these ovens are held at a temperature set point that changes with the intention of having the clay heated to a degree that when we pull out our clay block, which is the mechanism by which we fixture the plate to determine if it's a partial or complete penetration, we want that clay to be calibrated so that when I pull it out and I take it over to our drop fixture here, I drop it with a steel ball, we want that depth of deformation of the clay to be a certain number plus or minus a tolerance. And so all of these ovens are to make sure we run, I believe we have 10 blocks, clay blocks that we're currently running. Those blocks are 24 inches by 24 inches, 6 inches deep, filled entirely with clay with no air voids. So that's an important part of our conditioning process. When we pack a block, when we shoot a block, and when we repair a block, we need to make sure that we remove any disturbed clay, any FOD, foreign object debris, articulates, nylon foams, fibers, anything that might be embedded in the clay. After we shoot, we need to make sure we remove that. And then we repack new clay into that block such that there are no air gaps and voids and it's a monolithic, homogeneous material across the block. So clay block preparation and care is an important part of what we do, and a big chunk of our time spent making sure that our clay blocks are cared for appropriately. This particular oven stores what we call templates or preforms. As you'll see here, we've got a bunch of racks in here that store something that looks like this. And so as you can imagine, a single curve or a multi-curve body armor plate, if I were to put that on a flat surface, again, we would be inducing air gaps. And air gaps are essentially the free energy path for energy, which is what ballistics is, right? So when we shoot a plate, what we don't want is an air gap to disperse that energy, because then we're not going to reflect in our clay what's really happening behind the armor. And so we need what we would call, again, a preform or a applique, clay applique, that fills the gap between a multi-curve or single curve plate and the clay block.
Gotcha, yeah.
And so when we go through this process, we have two, as you'll see on your right here, two general shape curvatures of reinforced concrete reverse molds. What we do is we take a prescribed volume and weight of clay, we pound that into this general shape, and then that gets us 80% of the way there for most plates. When we receive an armor that's to be tested, we then take that specific plate, we take the applique mold, and we form that, we roll it out, we stamp it, we make sure it fills the gaps appropriately to that curvature. As you know, all plates are different sizes, shapes, curvatures, chamfers, cuts, all these swimmers cuts, full cuts, all these kinds of things, right? And so we want to make sure that for each armor that we're testing, we are making sure that the clay applique mold fits and fills those air gap voids perfectly, so that we're testing it accurately on the clay block. So like I said, what is prescribed here in terms of the control of these is not so much the temperature that the clay is kept at, rather the performance of the clay during a calibrated drop. So as you'll see over here, this is our drop fixture. And so you'll see an outline here for clay block, again, 24 inches by 24 inches. The clay blocks that are kept in this oven, when it's hotter here in Arizona, we lower this temperature. When it's colder, we up the temperature. And this is kind of an empirical thing that we've learned and data that we've collected to kind of understand where our set points need to be. But essentially what needs to happen when I'm going to shoot an armor, as we'll do today, I will pull a clay block out of our oven. I will throw it right here. And we've got 5 distinct magnet points up top, and these are prescribed by the NIJ at a prescribed height from the clay block surface. And I will place this sphere, again, which is all denoted and described by the NIJ, the weight of this, the density, the shape, all of that prescribed by the NIJ. But the clay block, like I said, placed here, 5 magnet locations. I turn my electromagnets on, balls placed on each of those, and then dropped into the clay. 5 distinct drop locations. I then pull the block off. I take my depth gauge, zero it on the clay surface, and I take the depth of that ball indentation at all 5 locations. The NIJ specifies that when I shoot an armor, I am to do pre-drops, so that means before I go in and shoot, and I am to do post-drops after we shoot, to make sure that the clay stays calibrated throughout the length of the test. And the calibration depth thickness nominal 19 millimeters, plus or minus 2 on the average of the 5 drops, and any given drop can be 19 millimeters plus or minus 3. So anywhere from 16 to 22 millimeters in depth deformation, but again, the average being 19 millimeters plus or minus 2. That's how we know that the clay is at consistent, repeatable, and appropriate temperature to go up and has the required plasticine characteristics that any other lab would have. So even if my set point, even if, again, we're really hot here in Arizona, and we're a little bit warmer here in the lab than maybe we are somewhere else, we know that the clay is calibrated appropriately because both before and after plates were shot, we've done the calibration and we know the depth of drop. So you'll see in here, I'll show these to you while they're in here. We've got a couple of clay blocks per oven, obviously all held at the various temperatures to make sure that we're calibrating appropriately. Like I said, we've got 10 blocks packed. We're typically running 5 V50 blocks and 5 V0 blocks. The difference between V50 and V0 testing being V0, 0% of the projectiles are allowed to pass the armor for a passing result. So all of the projectiles we shoot at V0 should be stops, intended to be stops. Anything that penetrates the armor would constitute a failure. V50 testing is also referred to as ballistic limit testing, and that's to test the limits of the armor. So we want to understand the velocity at which 50% of projectiles would pass through the armor. This gives us a statistical level of confidence across a wide swath of velocity ranges that the armor will perform in a predictable and reliable fashion. And so there are prescribed velocity tolerances on V50, but essentially what we do is we shoot at a prescribed velocity. If the armor stops, we increase in velocity, and so forth if we continue to stop. And once we see a penetration, we would reverse course and reverse velocity. So we see another reversal in partial or complete penetration, and we would try to hone in on that partial complete velocity, which we would call the V50. And there are regression mathematical methods that we do and calculate here internally to provide additional insight and information, an S-curve of performance across velocity from a 0% probability of penetration all the way up to 100% probability of penetration. And we provide those statistical tools and analysis to people who want to perform ballistic limit testing to understand better how their armor's performing, where there might be performance enhancements available, or where their armor might be short across different threats, and different threats perform differently on V50. So it's important to understand, especially for material suppliers, what is the V50 of this material at a prescribed aerial density, and helps them better understand and characterize their material, and understand then translating that into armor manufacturers, how thin can I go and how light can I go to be confident in the performance of the armor. Yeah, so 3 clay ovens, like I said, we run in those 10 blocks, 5 V50, 5 V0, and we store them in here. We also do have electronic in and out of our blocks. It's important, as specified by the NIJ, if a block is out of the oven and being tested for more than an hour, you need to return that block into the oven for at least 3 times the amount of time that it was out. And that's just their rough order of magnitude way of making sure that I'm not shooting on the same block repeatedly. As you can imagine, heavy, high-frequency impacts like ballistics will warm my clay up significantly. Last piece of big equipment here is our mechanical durability drop tester. We will actually use this today when we're testing those plates. They are to be dropped, so we will use that. This is a 48-inch tall lever arm drop tester. An armor is affixed and placed on that square up top with 10 pounds of that conditioned clay on the back, and it's dropped twice on its face. The intention there is to target the highest point, as you can imagine, of curvature on the plate, what we call the crown, the highest point, intended to be met on the hard surface, dropped twice. And that is a prerequisite for the ballistic testing for all of hard armor that you're doing for ballistic resistant testing. This is our loading table. So we typically don't buy boxed rounds, we buy projectiles, and then we buy brass. The reason for that is we have specified tolerances on the velocities of each projectile. And in ballistics, I can shoot a projectile at a prescribed grainage and weight, one shot, and 2 minutes later I can shoot it again and the velocity will change by 20 to 30 feet per second. And so in order to maintain within the tolerances that we have, which are typically plus or minus 30 feet per second, we hand load each projectile. And so you'll see here we've got brass laid out, we have projectiles laid out, we have grainage, which is automatically measured, so we input our grainage down to the 10th of a grain. We also weigh our projectiles down to the 10th of a grain so that we can make sure we're consistent and controlled. As you can imagine, a 60.6 grainage M855 is going to fly differently than a 63.3. And so we accommodate that accordingly, try to shoot them in batches according to the 10th of a grain of the weight of the projectile. We track all of that on the computer. We have a large swath of velocity data, velocity curves across various powders, various grainages of projectiles, in different cases, because we can shoot various projectiles out of different casings depending on the velocities we need to achieve.
How much variance is there in, if this is a 62 grain M855 or something, I'm seeing them all over the place in here, like as far as weight goes.
Yeah, and typically the NIJ, if you were to review the NIJ 0123 standard, they do give a tolerance on the grainage. And I believe, let's take for example the M80, the RF1 projectile. I believe that is nominally set at 148 grains, and I believe that is +3, -1, or 0.
Interesting.
And so that is, the military has done some work on that for their programs on what's
allowed.
If I were to find the M80, where am I typically going to find it at? Because it is a pretty controlled, anything that's designated with an M is a military round, right? And so it's relatively controlled. And so they did some work to say, okay, here's generally where those bullets are going to come in at, and they assigned the tolerances appropriately. If I were to shoot one here and I were to shoot one here on the two ends of the grainage, I would maybe see 50 to 100 feet per second difference in velocity with this smaller projectile. So it's not huge when you're talking about the grand scheme of things, but for us, in terms of controlling plus or minus 30, it's very important that I know what I'm working with on each of these projectiles. For example, if I'm shooting today, I might take 62.5 and shoot exclusively 62.5. That's just another variable I can control.
Write that down in the test.
Yep. And, like I said, rifle and handgun, different holders. You'll see right here, we have all the different holders for the cases, the flat cases. And yeah, so what typically the operator one, which would be Ryan today, is the one who is physically loading the projectiles, recording all of our relevant information on the computer, and then going back and forth and making any incremental changes as needed to make sure we stay within tolerance and velocity ranges. And we're running N133 powder. That's typically what we'll run for rifle stuff. If we need a finer powder, like maybe the lower velocity 9mm, we'll run Accurate #2. We've got a bunch of different powders, including IMR and a bunch of other ones that we'll typically use. We have velocity curves and historical data on all of them. So for example, if I'm shooting the M80 and I need, as opposed to reference velocity for M80 is 2,780 feet per second, if I need that closer to 3,200 feet per second, I'm gonna run that out of a bigger casing, and I'm gonna probably run that with a different powder. And so all different things that we're tracking and making sure we understand, and if something does come up where we need to have a higher velocity, we have a go-to on our velocity curves and data so that we can kind of at least get an idea of where we wanna sit for that. Range right here, obviously we'll go in there in a moment. This is the control table, so this is where Ryan's gonna record all of our information. We have the chronographs, Oler model 37, I can't remember what the model is, but Oler model chronographs, Oler model light screens down there that remote into this computer. So you'll see here, these are our controls for those chronographs. So essentially what we're doing to monitor velocity is, you can imagine, velocity is distance over time. So if I have two pieces of equipment at a specified distance from each other, and I can trigger when something passes this one, and I can trigger when something passes this one, I have time and I have distance. You can back out velocity. So that's the function of the light screens. We have two redundant sets at prescribed distance apart. Set 1 is 5.33 feet apart. Set 2 is 4.33 feet apart. They will both generate an independent reading, and typically we have some prescribed tolerance that those numbers need to match and agree with to make sure we're confident in the velocity result. But two redundant sets there that will read back here upon firing of the projectile. Then we have our test order collection. As I mentioned to you, we're tracking our receiver number, our barrel number, the threat, powder lot, all of the asset numbers for the equipment that we're using, the clay block number, the temperature, the drops, the time, the operators, all of the information recorded on our test data collection, so that if we needed to repeat this test, we could, down to the number of the caliper that we're using to measure backface signature.
Now, when you want to increase velocity, say 100 feet per second, are you able to accurately go, increase powder weight by this much and we'll get 100? Or is it kind of trial by error a little bit?
To some degree, and not so much trial by error because we don't know, but trial and error because ballistics are so finicky.
Right.
So for example, if we were shooting a V50 and we shot at reference velocity and we wanted to go up 100 feet per second, we've got thousands of historical shots that we could reference and to say, I know exactly, and we could be plus 75 or plus 80 or plus 100 on the dot or plus 110. And so this is the nature of the ballistics, but yes, generally speaking, we know the velocity increments from our historical data on what we should or should not increment.
Doing it.
And again, that's saved on the drive, so any operator who's here who doesn't have firsthand experience would pull that velocity historical data, get an idea. And we do shoot warmers every time we're shooting a projectile for the day or we switch barrels. We leave the block down, we don't put any armor up, and we shoot a couple shots. We want to make sure that the bullet's flying right, our accuracy is appropriate, and we're having repeatable results on our velocity. So we get kind of an idea, you know, from day to day, I could have one powder load for M80, and the next day I got to go up 0.1 or 0.2 grains on the powder load.
Yeah.
And that's just a difference of temperature, humidity, and fouling in the barrel, and the variance in the projectiles, all these different things that come into why ballistics are what they are.
Right. Because ballistics are generally somewhat finicky.
Yep. And so we're doing our best to control it, and
Yeah.
I think we do a pretty good job of it. So that's why it's
awesome.
obviously important for anything that could come back to us as a reason for a test failed, we want to mitigate.
Yep.
And so traceability is a big part of that. So making sure that operator one, Ryan, today is recording that is important and crucial. All right, I'll take you in the range. So we have our universal receiver table here on the floor. We have our carriage system here with our universal receiver. So this portion that you see here outside of this barrel nut in the barrel is what we constitute as the universal receiver. So this is the piece that stays in the range 24/7 and can accommodate all of the different chambered calibers. And so typically the main features of this obviously are our hammer here that is pulled pneumatically and fired from outside of the range. A lot of ranges have the pull string that goes through. We just have a pneumatic pull system that pulls this back and yanks our hammer out. So fired pneumatically outside of the range, pneumatics running to the outside. And then the barrel that is interchangeable. So right now we have 5.56 up. If I were to want to change this barrel, I would loosen this barrel nut, I'd pull this barrel out, and you'll see all of our stack of barrels sitting over here, numbered and cataloged. And we'll pull a new barrel and stick it in there, and that is when we would then shoot, as we mentioned, the warmer shots to make sure that our accuracy is appropriate, velocities are appropriate, and we'll make sure we're not seeing anything errant or strange that we need to look into further.
Yep.
All of our spent brass down here by caliber, we'll toss that in there obviously after a shot. Typically, procedure for us up here is operator 2, which will be myself today, is in here loading the bullet. When the bullet is in the breech, the range is hot, operator says range hot. Once the range is hot, door is closed. Operator 1 or 2 is to the last person in the range. So if you guys are down here and we're looking at stuff, we'll have you guys get out. We'll load a bullet in, range is hot. Once the range is hot, door will close. There will be 3 beeps on the tower up top to let you know that the range is hot and the bullet is about to be fired. Upon 3 beeps, well, before 3 beeps, cover your ears or put ear protection on, projectile will fire. I will come into the range, I will clear the breech, pull the brass out and say clear. Once I say clear, everyone is free to walk down range with me and go view the armor or anything else that we're looking at down range. You'll see here everything in the range is on rails, so we can move that to any prescribed distance. We do have hard stops for the very specific ones. You'll see here, we have NIJ 10106 handgun. We have a 10107 handgun for our start screen. And that just makes sure that obviously our light screens are where they need to be to measure the velocity appropriately. And that is specified by the NIJ when we're doing certification testing. And then you have our light screens. So you'll see here set 1, set 2. And these are the measurement tools through which projectile passes. It's a light screen because it detects disruptions in light, and that's how it knows a projectile passes. Really? So when you disrupt this sensor on the bottom here as a projectile comes through, we'll read a measurement to Ryan to say this is the time it passed screen 1, this is the time it passed screen 2. Like I said, 2 redundancies on that, and then it will reflect those back to the remote computer. He's out there and he can get a velocity from those. Yes, so then this is our target stand here. You'll see 2 movable spall walls on either side, steel spall walls. These can move with the target stand. Target stand is automatic up and down, and then a manual left and right. So we've got grommet straps here. These are, you'll see the kind of hook and loop straps on the back here. We just cut them in half and grommeted them to the bottom, and that's what folds over and goes onto the back here to fix the armor. But this is our target stand. The big bulk of this here is to make sure nothing obviously goes through the back, even if we penetrate through our clay and through the armor. So we've got a bunch of reinforced AR500 steel on the backside here, and that's replaceable. So when it bows, and eventually it does, we just unscrew that and bolt new layers and sheets of AR500 steel to reinforce the target stand. And then obviously behind the range, a bunch of layers of steel for protection, and then outside the range as well, steel for protection. You'll see here, this is our measurement tool for backface signature measurements. When the clay block is up here, there'll be a long edge and a long edge here that will register on this side of the caliper, the bridge gauge. Then the caliper will go in with a ball tip. We will register off the location of the clay where the shot location should be. We'll come back down here after the shot. We'll measure the depth of that signature, and that's how we record our backface signature measurements. Drop. Drop. Drops. 1867. 1868. Important thing that we need to capture in the clay,
Well, in the
which
commercial
we did,
market.
as you can see, is that shockwave that propagates through the armor and hits and does make a decent dent, even though it may not seem like that on the outside. So that's your 6 shots.
Oh.
Not that actually. So with RF3, still need 36 shots. There's only one threat in RF3, so you're only shooting the 30-06. You need 36 shots, and with this one, you can choose 1, 2, 3, or 6 shots per plate. Any of those you can certify to. The nuance that's important to note here is regardless of how many shots per plate you choose to pursue, that will not be reflected on the CPL, the compliant products list, nor will it be reflected on the label. So if you had a all 3-shot RF2 plate and an all 6 RF2 shot plate, it would look the exact same on the CPL and on the label. You can advertise it as, hey, it took 6 shots as opposed to 3, and I'll know that because I have to test it and fit to those shots. There is no distinction on the CPL. The only real advantage you see is decreasing the number of plates that you have to submit for cert. I don't want to call it a gap, but education is big here.
Right.
Because to some degree, yeah.
It leaves room for some
It leaves room for
shenanigans.
marketing
Yeah.
that is outside of the scope of what the CPL is offering you. So,
kinda
for
sucks.
example,
Yeah.
you might see somebody say, well, my plate's better because it's a 6-shot plate, or my plate's better because my RF2 plate's lighter, but it only stops 3 shots, whereas a slightly heavier plate may take 6 of all of them, right?
Right.
And so I could just market that to you and say, well, I have the lightest RF2,
But
it's only
not
3
say,
shots.
yeah.
So there's some, again, and the NIJ wanted to not try to create levels within levels, which is why they're not reflecting the shot numbers. But it's important as both distributor and armor manufacturer to know that and be able to articulate that clearly. Whether that be in your marketing material or your TDS, whatever it is, I would articulate, hey, it's 3 shots per plate of M80, it's 6 shot of the rest, or any combination thereof.
So a smart consumer, like law enforcement or a civilian, could ask the company, was this plate a 3-shot or a 6-shot on the RF2 test?
Yes.
And they may get a customer service response saying it or not, but they could ask
Yes,
that.
they absolutely should ask that. And this is also where I think test reports are valuable. So if I'm testing this in fit, I am required to test to the number of shots per plate that you prescribed.
Yeah.
So if I give you a test report and I'm a consumer, I would ask for the test report. I want to see the 6 shots. I want to see the 3 shots. I want to see whatever it ends up being. So you do have to achieve the 36. For example, what I think is going to happen here with the RF3, this is a nasty round.
Right.
The RF3, the 30-06, and typically tends to crumble ceramic well and effectively across the surface area on one impact. There are plates, and I'm sure there are manufacturers who can stop 3 shots of the M2AP. What I would recommend, certify to 1, submit more plates, be safe, so that you don't have any you don't have any issues with the ceramic cracking and you're punching through on 1. You know you can stop 1, and then just market multi-hit capability. Tell it, hey, well, it's only certified to 1 shot, but it takes 2 shots or it takes 3 shots. And this was what 06, everyone did this with 06 with level 4. You could only ever certify level 4 to 1 shot. But you'll see today, you can go on anybody's website and you see a multi-hit level 4. Well, it doesn't really exist because you can only ever certify to 1 shot, but you can have independent test results that demonstrate multi-hit capability. And so that's what I would recommend, again, just to be safe, because what you don't want to have happen is on a 3rd shot or a 4th shot, just by trying to save plates you submit, something punches through or something weird happens. You want to be there. So that's just in general an example of how the shots per plate and shots per threat work as it relates to communicating that to your end consumers. This is somewhat of a gap that, like I said, I think education is important to reflect. Typically, as we're relating this to 06, a big difference too with RF1 is previously it was just the M80 ball. That was the only test threat that you needed for level 3. We've obviously now added 2. And typically, again, as we talk about umbrella of protection, typically mild steel core and M193 generally fall under the M80 level of protection. However, there are certain materials that are more vulnerable to the steel core projectile punching through just because it's a harder material. There's different characteristics, physics that go into that particular core. So the NIJ thought it prudent.
Like ceramics in particular? Or?
Polyethylene, fibrous reinforced composites, generally speaking. So generally at the RF1 level, you'll see monolithic polyethylene being the material utilized to achieve said protection level and the weights associated. When you make the jump from RF1 to RF2 is typically where you see people start to add in a hard strike face material, whether that be steel or ceramic.
And multi-hit and defeating multiple hits of M2AP is realistic and reasonable for plates.
Absolutely. The Zach, is it the 4111, 4100 model plate? Typically we shoot, when they request quality plates from us, we typically shoot that with anywhere from 2 to 3 shots of the M2AP. Not that they market that to stop it, but they just kind of want to get their error bars, which is another thing that I think is important to note with Hesco. When we get quality or R&D plates, they market a plate as a one-shot M2AP plate. They will frequently ask us to shoot 2 or 3. Let's see where our error bars are and understand this plate a little bit better. And so, yeah, absolutely. There's certainly models that can stop. And then these are all design considerations that you go through as an armor manufacturer and understanding what characteristics aid in the multi-hit capability. You need to keep your ceramic together is essentially the crux of it. And two, with the RF3, a big factor that Hesco knows well is a strike face foam, because I have to drop the plate, and with a thicker ceramic tile, typically, which we see with a level 4 or RF3 protection, is more conducive to cracking. And if I had just so happened to hit that M2AP on a crack, you're smoking through it. So typically what people will do is they add an energy dispersing material to the strike face of the plate, and then it's just like dropping it with bubble wrap, right? So it protects that ceramic on impact, keeps it from cracking significantly, and allows you to pass the drop test and pass ballistics. So armors are no longer just tested perpendicular, they're now tested at an angle.
Oh, wow.
So this is an introduction of a whole new dynamic, which the NIJ found critical to the wearer's safety. And so what's going to happen typically, you'll see, we said the 36 shots per threat across the board. So 36 of the M80, 36 mild steel core, 36 M193 and V0. We have 24 of those at 0 degrees and 12 of them at 30. The way that the specification is currently written, one of the shots goes away from the center line. They are changing that in an administrative clarification. All of the shots will go into the center line.
Okay, so they won't do like away and then on the inside.
Correct. Everything will point towards the center.
Gotcha.
Which behooves the manufacturer. And it also behooves us in arbitrating what is a complete and partial. Because if I'm wearing an armor and I get shot like this, and there's spall that goes over there, the armor's done its job for me.
Right.
But in my clay box, I can see some spall. So is that a partial? Is that a complete? That was a question we brought up with the NIJ, and we resolved it. We said, let's put everything into the middle. And that's going to make it clear for us to arbitrate whether it's a partial or a complete penetration. But even on level 4 plates, for example, if you're shooting all one-shot plates, 24 plates will be at 0 degrees, and 12 of those plates will be at 30 degrees on that one shot. So these are all partials. So all stops in plate, nothing penetrated the plate, but you can see obviously the cascading of this material.
Right.
And a lot of that has to do with the shot to edge distance. This is probably still within tolerance of shot to edge, about 2 inches. But you can see the reason that polyethylene, these types of composite-based backers have trouble with edge shots is because of the cascading of that material. So you can see that material pulling in, sort of cascading towards where the deformation of that bullet entered. And so it is a stop. This would be a passing plate, 2 shots under 44, the rest of them were stops. But just a nice illustration kind of that defeat mechanism that you see closer to the chamfered edge on these polyethylene.
Yeah, that's super cool. Since 2019, we've been offering Hesco body armor to tens of thousands of customers, and it's primarily been civilian sales. Generally, law enforcement agencies go directly to a company like Hesco or submits a bid to many armor companies to provide product for. But we've been able to target civilian sales and provide a streamlined process for people to see a small selection of Hesco plates that we curate and then be able to purchase them because they're in stock, and we do stock them quite deep, and they're able to get them in a very short amount of time. This is particularly important when times are getting uncertain and people may not have gotten prepared ahead of time, but they all of a sudden want to get some body armor to level up their capability beyond just owning a firearm. This trip has confirmed for us that Hesco was the right choice when we selected their company back in 2019, and I look forward to working with Hesco even further in getting even more of this armor, hopefully hundreds of thousands of plates, out to citizens all over the country.